Our next session is with Jeremy Lickness and Shai Bojanski, and they're going to talk to us about Entity Framework Core 5, the next generation for data access.
Hello, and thanks for the welcome.
Hello, everybody.
Yeah, my name is Jeremy. I'm a program manager on the .NET data team. I'm here with Shai. Shai?
Yeah, so I'm Shai Bojanski. I'm an engineer on the EF Core team.
Awesome. So we are bringing to you EF Core 5, which is the feature complete release that we just announced this morning. Super excited to share with you some of the new features that are coming down the pipeline. First, for those of you not familiar with Entity Framework, I have a quick and gentle introduction. What is EF Core and why should I even care? So at the end of the day, Entity Framework Core is a data access API. It's an object relational mapper, and we put that in parentheses because we also support non-relational databases like Azure Cosmos DB. We target .NET Standard 2.1, which means anywhere .NET Standard 2.1 is, you can use Entity Framework Core. That's your Blazor, Xamarin, ASP.NET Core, WPF, WinForms. It's across the spectrum. At Microsoft, we support SQL Server, which includes Azure SQL Server, SQLite, and Azure Cosmos DB, but there are many other databases that are supported both by the community and other companies. You can see that list at the link here, aka MS EF Core providers. One of the benefits of using EF Core is that you can use the strongly typed query integrated language, or language integrated query, I should say, link to specify your queries. We're going to show you examples of that. We also implement unit of work out of the box, so Entity Framework Core will track changes and even handle concurrency for you. Finally, it's data binding friendly out of the box. So if you're using WPF or WinForms, for example, as data binding frameworks, it plays very friendly with those. So let's take a look at the basics really quickly. Here is a plain old C# object. I have a class that has some data annotations. These are probably so that a form can display the right messages, etc. Out of the box, Entity Framework will look at this and instantly assume ID is a primary key. It has certain conventions that are built in, but you can override those. Everything is configurable. Here we have data annotations. These are optional, but when they're present, if you're using Entity Framework Core to generate your database, it'll take hints from these. For example, the size of the column, whether or not the column is nullable or not. Now I've added what's called a navigation property. From this entity, I'm referencing a set of other entities. Entity Framework will automatically understand that this needs to set up a relationship to other entities. Everything starts with something we call the data context or the DB context. I say that's where all the fun happens. This is how we really describe the interface between data and our C# domain or F# domain, any of your .NET applications. So here we're injecting some runtime configuration. We'll talk more about what that looks like. This is a DB set. The DB set is how you tell Entity Framework that here's an entry point to start mapping an entity to the backend database. We also have fluent mapping with what we call the model builder. So for example, I might not want to keep a timestamp on my class because it's not needed in my application, but I do need it in the database for concurrency. So here I'm creating what's called a shadow property, which is a property that Entity Framework will track without us having to have an explicit property on the entity. And here we're telling it that this is a property you use for concurrency, and I'll show you what that looks like. So let's configure a data context. I'm in an ASP.NET Core application. I'm adding my dependency injection services. Here I'm configuring a factory. Our recommendation in ASP.NET Core and Blazor apps is to create a data context per operation. It's very lightweight to generate one of these. So this factory will give us a mechanism to obtain new instances. And here we're configuring it to use SQLite. And SQLite takes a very simple connection string. It's just the path to the file. If this was SQL Server, I could pull this from environment, from secrets, from Key Vault, etc., and pass that in. Now I have my data context. I want to query something. Here I'm creating the context using my factory, and then I'm asking for a list of contexts with some filter. This is link syntax. It's filtering city, ordering, skipping, taking, etc. And what that turns into is an actual query. Now, this is SQLite. It will look different for SQL Server or for other database providers, but that's part of what Entity Framework does for you, is it makes that translation based on where you're running the query. Let's take another example. I want to update a contact. So here I'm grabbing a contact from the data context, and because I get it from that interface, Entity Framework is constantly tracking it and watching for changes. So notice I'm just changing 2 properties on that class, and then I'm saving changes. Entity Framework is going to be smart enough just to update those 2 columns, but it's also grabbing that row version so that we use what's called optimistic concurrency. If that record isn't hit, we know it's changed underneath the scenes so we can handle that scenario. So now that's your 5,000-foot rapid pace introduction to Entity Framework. Let's talk about some of the new, improved, and exciting features. I'm going to jump into a demo that covers some of the diagnostics features. So let me pop over to my .NET 5 application. So here I've got a class called something because I wanted to demo something for you. And I mentioned that we need a DB context. So this is a DB context that I'm configuring. It's pretty simple. We're just attaching some things and we're injecting these options for configuration. If I come back to the top, I've got a top level application. I'm creating a connection string. I have a database setup. So if you run this sample yourself, it's going to go ahead and populate it with some data. We're going to show some counts. And then down here, we have a query that's filtering for active things that were created in the past week. And then it's using something called a projection. We don't need all of the properties on that class. So we're just asking for these 2 properties. So let's go ahead and run this. Make sure our live demo is ready to go. So it says it's ready. So notice I have 10,000 things and it's pulled 5 because of the take 5. And here we've got our dates, etc. Now let's say I'm not trusting the system. Maybe there's a problem with my query. Maybe I want to make sure we didn't pull back 10,000 things and then filter them that way, because that would be inefficient. What are my options to troubleshoot and dig into this? Well, the first one I want to show you is just as simple as debugging your application. So I'm going to set a breakpoint, jump into debug. We'll let it run to this breakpoint. Give it just a second here. So now we're in the breakpoint. I'm going to hover over this query and show you something that is specific to Entity Framework, which is this debug view. If I expand this debug view, I get an expression, which is going to be the programmatic syntax for the query. So no matter how it was built up, it's going to be finalized in this expression. The other thing I can show you is down here. Let me hover over again, debug view. We have this query. And if I open this, this is the actual query that's going to be sent to the database. Now, again, this is SQLite syntax. If you're using SQL Server, this would be SQL Server syntax. But you could paste this into a management console and run it as is. So that gives you a straightforward way to troubleshoot. But let's assume that I don't want to just debug interactively because that doesn't scale. I want another way of grabbing that query. Well, we've got a special extension method called query string. And this will actually analyze that query and produce the string that's going to be sent to the database. So I'm just going to do a console write line with query str here. Let's go ahead and run this again. And of course, the build's going to take a second, so I'll spin my mouse, bring this over. Now notice right here, we got that exact same thing we saw in the debug view. This is the actual query that's being sent to the database right here with the parameters and everything. So that's another way that we can view it. But I want to show you one last way that we've simplified diagnostics. So we've always had support for loggers. And this is the logger factory, logger providers, etc. But we added a new option to make very simple logging, and that's called log2. And what log2 does is it takes an action that takes a string. So I'm just going to go ahead and send it straight to console.writeLine. And it also takes a logging level. So we'll do log level, I'll do information. And that's all of the configuration I need to add this new simple logging. I'm going to run this in debug one last time. Hit enter, blow through my breakpoint, and find my application here. So now we've got a lot of information. We see that the DB context was initialized. We even have this warning that tells me I used a take without using an order by. And for some databases, that can produce inconsistent results. I might get random 5 records because I didn't order them before. So it gives me those detailed warnings. Then I get the query, then I get the results. So this is a way, if you have issues with your applications or you just want to understand what's going on behind the scenes, you have several options to peek behind the curtain, if you will, and see what's going on. So now, having covered that, I'm going to turn it over to Shai, who's going to look into some of the new, what we call mapping features, many-to-many, table per type, and show you an awesome demo of how these features look. Shai, take it away.
Yeah, so hi everyone. I'm Shai. I'm an engineer on the EF Core team. So the first feature I'm going to cover here is something that users have been asking for quite a while, and that's improved support for many-to-many. Now, anybody who's done a bit of database programming knows about many-to-many. It's quite simple. Let's say you have a bunch of users here, and you got a bunch of groups here. Many-to-many is the fact that one user can belong to multiple groups, and the same group can also have multiple users, right? So hence the name many-to-many, right? The way you do this in a relational database is you stick a table in the middle. We call this the join table or the association table. And each row in that table in the middle is going to link up one user to one group. So much for the theory. Now, obviously, you could have done many-to-many before EF Core 5 came along. Otherwise, it would not be a very good database access layer. However, there's a lot of cool things coming for 5.0. So I'm going to first show how things used to be done could be done before, and then I'll show the new nifty stuff. So we can finally look at some code very quickly. So what we have is a very kind of classical and easy EF model. So we've got a user with an ID and a name. We've got a group with an ID and a name. And we have this thing, the membership, which represents the thing in the middle. A membership has one user in one group, and it represents the linking, this association that we were talking about. If we scroll up, we've got, that DB context that Jeremy was mentioning. This is a very standard run-of-the-mill one using the log2 that Jeremy also demoed. And up here, we've got a bit of data to make things interesting. So we've got Jane and John as users. We got a football group and a movies group, and we're going to do some membership. So Jane and John, they like football. They're in that group. Jane likes movies, but John doesn't, apparently. We throw all that into the database and save it. It's that easy to do things with EF Core. And here we're going to just see a quick query to make this interesting. So we're basically going to query for all the users which have any membership whose group name is movies. So we're querying out basically users which are members of a group called movies. Let's do a quick run through this to see what comes out. So I'm using that simple logging thing to inspect the SQL exactly as Jeremy here told us. So scrolling up, I can see that we're creating a groups table, we're creating a users table, and a memberships table. Everything is pretty straightforward. The thing to note here is that for each .NET class that we have in our EF model, we have a table. So it's a very simple correspondence kind of thing. If we scroll down here, we're going to see the actual query below. It doesn't really matter. I'm not going to go into the SQL. The important thing is that we're going to see us producing the same thing later with different things. Great. At this point, so I'm a software engineer, right? So the thing I like most in the world is obviously writing code. There is just one thing I like even more than writing code, and that's deleting code. So the best thing in the world is when you got a feature that allows you to remove like a swaths of code and your program, continues running like before. There's nothing better for a software engineer. So what we're going to do now is switch over to EF Core 5 mode, and we're going to do precisely that. The thing with memberships here is that we don't really care about it. Memberships is just a detail. It's the join table. It's a detail about how the many-to-many is implemented in the database. But in our C# programming world, we don't really want to care about it so much. So what I'm going to do is EF Core 5, let's say bye-bye to that one. And we're simply going to go and have navigations from the group directly to the users. We're going to do the exact same thing the opposite direction. So this is exactly how we want to model things, right? I mean, users have groups and groups have users. We don't care about how that gets implemented behind the scenes. If we scroll up, of course, we no longer have membership, so our seating is going to change a little bit. All we have to do here is to see the users on their groups, on the groups themselves. So that's going to clean up quite a bit of code. Same thing for the movies. I think we had only Jane in the movie lovers category. And now we've seeded them, so we don't need all this. Look at all this lovely code going away. We're left with this. And obviously the query itself has to be tweaked a bit. So there's no more memberships, but we've got something better. We got the groups directly. So I'm going to just query the groups directly here. I'm going to change this identifier. And we've got a much lovelier query, right? Because it now says exactly what we wanted to say. Get the users where any of the groups has a name of movies. Okay, so we've removed all this code. We're going to run this again after having changed all this. And the thing to note, if I scroll up, is we still have those three tables here, groups, users, and group user. So this is a bit of magic. EF Core has basically looked at this. We no longer have a .NET type for this. That's why it's named group user, by the way, and not membership. But EF Core has understood implicitly that we want a many-to-many mapping, and it's created the join table for us. So we don't have to explicitly mess with those details, right? And that's pretty cool. If you look down here below, then you have the same actual query. So in fact, nothing has changed in the database behind the scenes. The only thing that happened is that we made our C# code much, much easier. And it's worth maybe stating that, you know, we have users and groups. Memberships are nowhere to be found, but they're there in the background, right? We are skipping over them. Okay, that's the thing, the important thing to know. Now, this is already pretty cool, and EF actually did this. EF Entity Framework 6 actually did what you've just seen. So EF Core now does that too, but we actually took it a step further in EF Core, and that's pretty cool. So what we realize is that pretty soon after you do something like this, your customer or some pesky manager maybe is going to come along, and they're going to ask to store some sort of data on the association. They're going to want to know something about that link between users and groups. For example, let's say we want to know when a user joined a group. So we want to attach what we call a payload property to that many-to-many association. Now, if we want to do this, we're going to bring back a little bit of code, which you just saw me taking out, but it will still be very cool in the end, trust me on this. So we're going to have a membership type here, again, that represents the join entity here. We're going to bring back the collection of memberships, just like it was before. But the thing to note, and that's very important, is that we're going to keep the users here. That's the key that I'm going to talk about in a second. So we have both memberships and users or groups here. Now, to make this actually interesting, I'm also going to pull in a query. Sorry, there's one more thing I have to do before that. So I'm going to put in a little bit of configuration. So this thing, don't be afraid, it's actually very simple and straightforward. It's us configuring EF Core, saying each user has many groups, and each group also has many users. So that's an explicit configuration of the many-to-many that was implicit before. And we're instructing EF Core to use memberships as the join entity. So we've basically gone back to exactly what we just had, only we're doing things very explicitly. I'm going to do this very quickly. If we again run this program, then we're still going to see the same query, and we're going to see the same three tables. This is a super boring demo because I keep showing the same SQL, but it is, you're going to see it's going to be quite interesting. So the thing is once I've done this and reintroduced membership, now I can introduce my payload, which is member_since, a timestamp for when the member joined the group. And now I'm going to pull in this quick query just to show you that I can. And our query is to take all the users where any of the membership they've been a member of since 2000. So basically, we're querying for old timers, for people who've been members since 2000, maybe because we want to send them a gift bag or something similar. Now, I'm not going to run this because the actual query isn't very interesting, but the really, really, really cool part here is that in this query, we indeed are referencing the join entity, and we're looking at the payload property. But right here, we still have our old query, which doesn't care about it. This old query still skips over the memberships table or entity and goes directly from users to groups, and we don't have to mess with those details. So EFCore doesn't force you now, EFCore 5 doesn't force you to deal with that detail in the middle. It just lets you skip over that property, if that table, that join table, and cleans up your code. So that's a pretty good feature, at least we think so. And with that, I'm going to jump to my second feature, which is a new way of doing inheritance mapping with EFCore. So inheritance mapping is basically what this means is that you have a hierarchy of .NET types, right? Like a normal hierarchy, base class, subclass, all that kind of stuff. And you want to map that to a relational database. That's not trivial. Now, EFCore has once again supported doing this since the very beginning, but EFCore 5 introduces a new way to do this. So I'm going to quickly go through how this used to be done in EFCore before 5, and then we'll see the good stuff. So I'm just going to pull in a new code sample. It's very simple to the previous one. We've got user and group. We still have the same many-to-many relationship. But now, if you look at this, our user has a subclass called external user with an external company property. And there's also a time-restricted user with some other properties we don't care about. So all these we want to map to the database. It's quite a feat. Now, the fact we added these entities, which are subclasses, doesn't automatically make EFCore map them to the database. I have to have these two little things here, which basically let EFCore know about these two subclasses, and it lets EFCore know that I want EF to map these. If we scroll all the way up here, then we see that John has been converted to an external user who comes from an external company called Foo. And the query is really, really quite simple. We're basically going to query for all external users here, whose external company is Foo. All right, so I hope that's clear. So I'm just going to hit run on this. Reminder again that this is not EFCore, this is not specific to EFCore 5, what I'm showing you now. If we go up here and we look, we have our table creation SQL, we see something strange. Our users table has morphed. It's unrecognizable now. It has these weird properties on it. So it's got external company start time and end time. So what's actually happened is EFCore has walked our hierarchy. It looked at these three .NET types. It's taken out, it's kind of like pulled out all of these properties and put them in a single table in your database. It's basically folded an entire hierarchy into a table. So this strategy we call table per hierarchy, because there's one table for an entire hierarchy, or TPH, and that's been supported since the beginning of EFCore. Now, one thing that this mapping strategy, one problem with this strategy is, how do you know which row corresponds to which type of user? So you look at a specific row, is that an external user, just a normal user? So because of this, what EFCore does, it adds an invisible column. We don't have to deal with this in our code. It adds a discriminator whose sole purpose is exactly that. It tells, if you look at it, it will tell you this is an external user or this is a time-restricted user or whatever. If we scroll down below to look at our query is very straightforward. So we're going to query the table users, and we're going to look only for rows where the discriminator is external user, because that's what we want in link. And we're going to filter by the company. So far, so good. So this is the way the only way that you could do this in EF 3.1, for example. Now, EFCore 5 allows you to do a little bit of magic here, like a kind of a new feature. So what I'm going to do is I'm going to add a quick directive on the subclass entity, which is to map it to a different table. So each one of these guys are going to be mapped to a different table. That's all the code I'm going to change. It's that small, that simple. And I'm going to run this again, and you're going to see some pretty different results. So if I go up here, you can see that my users table has become very thin again. It's gone back to normal, right, to normal size. However, we've now added external users right alongside it, and we have external company on it. And down below, we're also going to see time-restricted users and so on. So what we have now is basically a table that matches every type that we have in our hierarchy. We call this table per type, or TPT. That's the new EFCore feature. The really important thing to notice here is that if you look at one single external user, like John, if we look at John, John is spread across two different tables. His name is in the base table, users, and his external company is in another table. That has some very important consequences. If we scroll down below and we look at the query, it's very different from our TPH query. Now, what we are doing is querying users and joining with the external users table. We have to pull in data from two different tables because that's the way TPT works, right? That's what we asked for. And of course, we apply the filter. So stepping back a bit, a lot of people have been asking for this because sometimes it fits their scenarios. It's also simple to understand because every class in your .NET model is going to have a corresponding table. So far, so good. However, it turns out that for databases, performing a join is not a trivial thing. It can be quite hard. So a join can actually be a source of a lot of performance issues. Imagine that you don't have two tables here, but you have a very deep hierarchy. That means that we're going to have to join a lot of tables here, like 5 joins or something like this. If you're joining 5 tables just to get John out, then that's potentially going to be a big performance problem. This is why we've introduced this feature, but what we're telling people, our users, is to still prefer the old or the existing TPH mapping strategy by default. It's perfectly fine to switch to TPT. That's why we introduced it, but we really recommend investigating perf and making sure you understand exactly what you're doing perf-wise before you use TPT. And that's about it. And with that, I think I'm going to give it back to you, Jeremy.
Thanks. And that's a great point. Don't take anyone's word for performance. Always test your application, see what's happening. So take a quick look at the link, aka.msefdocs. That'll take you to our documentation. We rolled out an entirely new documentation site to cover all these new features and reorganized it. So we look forward to you visiting, trying it out, and giving your feedback. And I think we'll look at some questions maybe.
Yeah, we have some questions. Thank you so much, Jeremy and Shai. That was an awesome session. Lots of folks have questions. So here's one of the first ones that we got, and we got a lot of questions around this. This is from Sergio. He wants to know, can I use records from C#9 for creating models in Entity 5?
Yeah, I can probably answer to that. So we've added a little bit of support for records from C#9, but the problem with records is exactly their strength is records are immutable by definition, right? So the problem with EF Core is that in general you're going to query something from the database, you get an instance, and then you're going to modify it. And as Jeremy showed before, change tracking, this automatic thing that EF Core does, is going to automatically detect the changes and save them back to the database. But with records, you're not mutating the instance that you got back from EF Core. You're creating a copy. So EF Core doesn't have any way of knowing that you've actually made those changes. Having said that, this is something that's very much on our radar, and we have some crazy ideas about how to make this work. But I would say that right now it's not necessarily a well-supported strategy, at least if you're doing change tracking. If what you want is to change track like you usually do, yeah.
Okay, let's see if we have time just for one more question. Let's see what other ones we have here. Ooh, lots
So
of
many.
C#9 records. Yeah, exactly. What about this one from Grease Trip? It says EF Core 5 support database first design.
Yeah, so what EF has supported what can be called database for, like, not just from EF Core 5. So what EF Core does is it allows you to scaffold, or sometimes we say reverse engineer, an existing database. That means that you point it at an existing database. It's going to look through your database, discover your schema, and produce a code model from that. So that's a sort of a database first kind of flow. What happens then can vary. So you can just take that and turn that into a code first. So you can evolve that now in code, or you can continuously reverse engineer. So your database can be your source of truth. And then every time you reverse engineer that into your back into code. And you can even use partials to evolve that, better. We have, again, some ideas about how to make the database first even stronger in the future, but yes. So the quick answer is yes. And that's actually not a new feature in EF Core 5. It's been improved, but it's been there also before.
Cool, awesome. Well, thank you so much, Jeremy and Shai. We're gonna, get ready for our next session that we have coming up. So thank you again.